Hello, welcome back to part 2 of the guided notes on graphing and solving, finding inverse functions. In the second part here, I ask you to find the composition of f of g of x and g of f of x. If your output, if your output equals x, then what that tells you is that the two functions are inverses of each other. So let's take the composition of f of g of x, which means take x minus 2 and plug it in everywhere into the f function where you see x. So that's going to be x minus 2, parentheses, plus 2. And what that gives you is x. Good. So now f of g of x equals x. And let's see if we can go backwards. Can we take g of f of x and get x as an output? That means I'm going to take x plus 2 and plug it in everywhere I see x in the g function. So I'm going to take x plus 2, parentheses, minus 2, and in fact I will get x. So because the composition of functions equals x, that means that the functions are inverses of each other. Okay, now in number 5 we can do the same thing. We can take f of g of x. We can take the g function 1/4 x plus 1/4 and plug it into the f function. So when we distribute the 4, it looks like we get x plus 1 in the parentheses and then minus 1. We sure enough get x. Now if we do this the other way and take g of f of x, what we get is I'm going to write the f of x function everywhere I see the g of x function, x in the g of x function. So I'm going to distribute the 1/4 and get x minus 1/4 plus 1/4, and that equals x. Therefore, f of x and g of x are inverses of each other. Okay, in the next one, give me a moment to erase. What we're going to do is graph the function, state the ordered pairs of the inverse, and then state whether or not, graph the original, state the ordered pairs, and then state whether or not the function is an inverse. So, is the first graph that we see a function? Yes, it is, because it passes the vertical line test. No x values repeat. Now, the original ordered pairs, I'm going to go with -2, 3, 0, -1, and 1, -3. The inverse ordered pairs are going to be 3, -2, -1, 0, and -3, 1. If you were to plot those, you would get 3, -2, -1, 0, and -3, 1. And here is the graph of that inverse relation. Is it a function? Yes, it is. It passes the vertical line test. Here we go. The original would pass the vertical line test, but it would also pass a horizontal line test, which means that its inverse will also be a function. Now, in number 7, is that upside down parabola a function? Yes, it is. It will pass the vertical line test, and every x value is paired with only one y value. The x's never repeat. So the ordered pairs here, let's go with these 3 ordered pairs, which are pretty easy to see. So that's going to be -2, -2, 0, 2, and 2, -2. Okay, I can already see a problem developing here. Let's see if you can catch it. Now, the inverse ordered pairs are going to be -2, -2, 2, 0, and -2, 2. So when I go to graph this, I've got -2, -2, I've got over 2 up 0, and I've got -2 up 2. So when we graph this, it's a sideways parabola, but is it a function? No, it is not, because this will not pass a vertical line test, and you probably could have told me in the beginning that the original won't pass a horizontal line test. Therefore, its inverse won't be a function. It won't pass the vertical line test. Okay, number 8, how does the graph of the original compare to the graph of the inverse? it's a reflection, we've talked about this, over the line y equals x. So we can think about it as switching the x and y points. We can think about it as a reflection over the line y equals x. Does the same thing, we're just thinking numerically and we're thinking graphically here. Okay, so now I'm going to give the equation of the function and write the equation of the inverse. I do that by switching the x and y values first, and then solving for y. So our original is y equals 3x minus 1. I'm going to switch x and y and make it say x equals 3y minus 1. Now I'm going to solve for y by adding 1 to both sides, and then taking 3y equals x plus 1, solving for y by dividing by 3, and saying that y equals x plus 1 over 3. So my new notation is f to the negative 1 of x. That means the inverse of x is x plus 1 over 3. Okay, you'll see in 10 and 11, pretty straightforward, switching the x and y values and finding the equation for the inverse function. In 12 and 14, there is a domain restriction for the very reason that if you think about what x squared looks like, if I'm trying to, it won't pass a horizontal line test. It'll pass a vertical line test, so it's a function, but it won't pass a horizontal line test, so its inverse won't be a function. So I have to make a domain restriction here so that when I do find the inverse, it will be a function. So I just have to eliminate, in other words, half of those x values. I'm going to only look at all x is greater than 0, which doesn't affect the process you're about to do to find the equation of the inverse. It just affects how you actually graph the function. Okay, your job is to fill in the answers for the next 5 of these, and then I will move on to part 3 in the next video.